Hi everyone, my name is Mohammed Sharir. The presentation is for class at CS 665, Summer O2. So basically, I'll be reviewing the article of DP Minor Design Pattern Discovery using metrics. So let's go ahead. Main motivation of this paper. So the journal article offers a unique approach to discovering design patterns by defining the structural characteristic of each design pattern in terms of weight and metrics. The process includes several analysis phases. The approach is based on the XMI standard so that it is compatible with other techniques following such standard. Main research problem. Due to lack of software architecture and design documentation, it becomes difficult to understand and change large computer-based systems. Once the system is deployed, the original design data and architecture is gone. It is then the source code which helps to comprehend the system. Due to its big size, it becomes hard to comprehend the source code. The recovery of the original architectural and design decision is imperative to comprehend the source code of a computer-based system. Hence, discovering of design patterns help in understanding the design decisions and trade-offs. It is helpful in future change of the system. This process can be done by adding or removing design elements in existing design patterns. When the source code helps in recovering pattern-related information, the developers can then easily change the system. Proposed solution. The journal article proposes a new approach based on metrics and weight to find out design pattern from source code. In particular, the system structure is represented in a matrix with columns and rows to be all classes in the system. The other matrix represents the structure of each design pattern. The discovering of design pattern with the help of source code matches between the matrices. A candidate instance of the pattern is discovered when the pattern matrix matches the system matrix. Moreover, the approach investigates the behavioral and semantic aspects of pattern discovery. This picture presents the overall architecture of the approach. The approach presented in the paper compromises of three phases. The first phase, structural phase, focuses on the structural characteristic of the system. For instance, classes and their relationships. The approach introduced by the authors is capable of abstracting structural information from system design into weight, metrics, and type. The structural part of each structural design is likewise represented similarly by weight, metrics, and type. In this way, the structural discovery of design pattern can be simplified by ascertaining and coordinating a group of numbers rather than mathematical components. The three analyses, namely structural, behavior, and semantic, are automated in the DP Minor tool so that the user only generate the XMI input from existing tools. Structural analysis. In the first phase, structural analysis, the authors propose to utilize weight and metrics to signify the structural information of the system and the design patterns to be found. The relationship between classes is of utmost importance during this analysis phase. Some relationships have to exist for each design pattern. For this reason, the authors encode the connection between the classes of a system design. To figure the weight and metrics, we can locate all fundamental data from the XMI file produced from source code with the exception of the dependency and aggregation relationships. The pattern instances found from this phase analysis contains false positives that are excluded in the later analysis stages. This table shows the prime number of structural elements. Behavior analysis is performed to find out the dependency that exists between classes and if particular class delegates the method call. As seen in structural analysis, the design patterns may have different behavior characteristics. Due to these characteristics, the analysis can be quite complex. One of the complexity is that there can be a range of possible implementation for similar expected behavior. In the approach followed by authors, source codes are scanned to find out different behavior characteristics of the design pattern. In the light of outcomes from structural analysis, the candidate of design pattern instances are already found out. Hence, search can be narrowed down to reduce scanning space. Semantic analysis. Majority of the false positive is eliminated in the behavior analysis phase. However, there are certain closely related design patterns which are similarly with respect to the structural and behavior aspect, but just different by their intent with which they are formed. The results from the analysis performed before helps in removing such design pattern instances. The three methods followed are searching the design documentation of source code, searching the inline comments in the source code, and getting clues from naming convention of classes. Alright, so the results using dpminer21 adapter pattern instances were discovered. The time taken for discovering these instances was 2.44 seconds after the matrix was generated. Some lessons that were learned were like mining the instances of design pattern from the source code of the software system that can help in the comprehension of the systems and the process of re-engineering them. XMI standard can be helpful in design pattern discovering, allowing seamless integration. Alright, so this is the final review. In this paper, the authors presented a novel approach to reverse engineering design patterns from source code. They introduced weight and metrics that facilitate the pattern matching process as arithmetic computation. Different from other pattern mining approaches, the intermediate representation is based on XMI standard, which allows our techniques and tools to seamlessly integrate with other tools following such standard. The approach includes different analysis phases, structural, behavior, and semantic analysis to reduce false positives. And this is the reference that I used. Okay, that's pretty much all my review is about. I hope you enjoyed. Thanks for watching the video. Signing off. Goodbye.